Welcome back to Algebra with Miss Swartz. Today we're moving on to section 3, which covers function notation. So we're going to talk about how we can write functions and how we can use the idea of a linear function to help us graph eventually. Today we're not going to do a lot of the graphing. We will put that in a little bit more tomorrow. But we are going to start by just kind of learning how to use our functions and how we can plug in certain values and evaluate with a function. So first of all, we have to know what function notation is. So this is very important. This is something you should write down. So using function notation to evaluate and interpret. So you've already figured out that, a linear function is represented by y equals mx plus b. By naming a linear function f, you can also write the function using function notation, okay? So this may be a little confusing at first, but it makes sense, okay? We don't always write y equals mx plus b. Sometimes we see it written like this. This is function notation right here, f of x, okay? What that means is, okay, we're trying to figure out the function of f that corresponds to what we put in as our x value. So we're trying to figure out what y would be based on what we've used for x. Okay, so we can use other letters. You could also have g of x. But essentially, whenever you see something that looks like this, okay, h of x, f of x, g of x, any letter of x with x in parentheses, you got to think of it like y. Think of it like there's a y there. It's just another way of writing it. You may be like, why would we write it that way? Well, eventually you may have a function within a function kind of thing. We may have y as another variable somewhere else. We can't always use y like that. So we have to have kind of a way to write things differently. You may even have something that looks like this. What is, a function of another function? Okay, and we're going to look at that down the road. So this is just a way to represent, because y equals y wouldn't make sense in this case, because we probably know one of these functions. We have to figure out how this works. So that wouldn't work. So we have to have a way to write it so that we're understanding what's going on. So essentially when you see these, you should think of an output of y, but it's just another way to write y. So let's look at how we use this. Okay, so it says evaluate f of x, evaluate the function based on x equals negative 4x plus 7 when x is 2 and when x is negative 2. So we're going to have two different answers here. We're going to have it when it's 2 and when it's negative 2. So we're going to do two different problems. Okay, so the first one when it's 2, so essentially what we want to know is the function based on 2, okay? Going to be represented. We're going to plug x in. We're going to plug 2 in wherever we see x, excuse me. Okay. We don't necessarily have to write the 2 inside here, but that just kind of shows you what it means. Why is that? Why is it f of x? Well, it's f of 2. Okay. Essentially, another way to put it is y, but we're going to write it as f of x. Okay. So negative 4 times 2 would be negative 8 plus 7. And so f of x when x equals 2 is going to be negative 1. Or f of 2 would be negative 1. Now if we plugged in negative 2, this would be 8 plus 7. That equals 15. So like I said, you don't have to always write it, but it kind of shows you what it means. We're plugging in 2 in this case for x. We're plugging in negative 2 in this case for x. So f of negative 2, or the function based off of the fact that x is negative 2, would give us 15. Okay. So then we have some story problems that go along with this. So let f of t be the outside temperature T hours after 6 a.m. Okay, so explain the meaning of each statement. So kind of in words, we want to explain it. So this is, okay, P represents the number of hours after 6 a.m. That's what this says. Okay. So F of T is going to be the temperature. So you're going to see that on the other side of whatever the number of hours it is. Okay. So for this first one, that means at 0 hours after 6 a.m., okay, it's 58 degrees. Sorry, we're struggling with my pen again. Okay, so 0 hours after 6 a.m., it's 58 degrees. So that means at 6 a.m., it's 58 degrees. Okay. B says F of 6. Okay, well, remember this is hours after 6 a.m. So 6 hours after 6 a.m., okay, well, count in your head. 7, 8, 9, 10, 11, 12. So at noon, it's N degrees. Okay. And then the last one, we have F of 3 is less than F of 9. So what does that mean? Okay, so this is at 3 hours after 6 a.m., so at 9 a.m., the temperature is less than the temperature at, well, 9 hours after 6 a.m. would be 3 p.m. Would that make sense that it would probably be less than? Well, probably, depending on the time of year and where you live. But at 9 a.m., the temperature is less than at 3 p.m. Okay. We'll do a few more examples where we're evaluating the function. Okay, so now it gives you 3 different options, so it wants you to try for each of these. So we want to know what f of x is when it's -4. We want to know what f of x is when it's 0. And we want to know what f of x is when it's 3. Okay, so I plugged them in. 2 times -4 is -8. Minus 5 would give me -13. So f of -4 is -13. 2 times 0 is 0. Minus 5 would give me -5. So f of 0 is -5. And then 2 times 3 is 6. Minus 5 is 1. So f of 3 is 1. So all I did was take whatever my x value was and plug it in where I saw x in the function. So I want you to do the same thing for number 2. Okay? I want you to find g of x for -4, 0, and 3. Then we have one other type of problem that'll be on your homework. And that's kind of going the other way. So it says for h of x equals 2/3 x minus 5, find the value of x if h of x equals -7. So now we're going to plug in -7 where we see h of x. So -7 equals 2/3 x minus 5. Okay, so kind of working backwards, what is x going to be if our function is equal to -7? So I'm going to add 5 to both sides. We get -2 equals 2/3 x. And then we have to multiply by our reciprocal here. So in this case, these will cancel and I'll get -3 equals x. Okay, and you could check that. See if this would work if you plugged in -3 here. Well, you would get -2 minus 5, which would be -7. So that would be our x value there. Okay, we'll do another example together. So for k of x equals 5x minus 10, find the value of x for which k of x equals 20. So we're going to plug 20 in for our function, k of x, and then solve for x. So again, kind of working backwards as to what we were working. So I'm going to add 10 to both sides. So I get 30 equals, work for me, 5x. And then divide by 5. I'm not going to show that because my pen's being dumb. Equals 6. Okay. So your homework's on page 72. Just to kind of lead you into what we're going to do tomorrow, we're going to take this idea, okay? So for like number 1 here, since x was -4, our output was -3, this would be considered an ordered pair. And we would be able to graph that. Same here. If x, I'll put that in parentheses, if x was 0 and y was -5, we could graph that. And if x was 3 and y was 1, because that's our output, we could graph that. And this would create a line, and that's what we're going to look at tomorrow. So that's all for today, page 72. When you're done watching the video, have a great day.